Hi dear students, here we are going to discuss one of the concept from your grade 11 chemistry for your NEET and JEE examination. The chapter is equilibrium and the concept is Chatelier principle. Let us first discuss about a equilibrium system. What about an equilibrium? See, in equilibrium system, in a reaction, the reactants are converted into products, right? This is called a reaction, a chemical reaction. Some reactants are combining together and we are getting a product. Is called what? A chemical reaction. There are two types of chemical reaction. One is called reversible reaction. One is called irreversible reaction. Let me consider in equilibrium, I'm discussing about a reversible reaction, which means you can convert reactants into product and products back to reactants. All right. If it is so, what is the name of this reactant to product and product to reactant? The reactants converted to products are called forward reaction. Forward reaction means reactants are combining together and we are getting a product. What about products to reactant? That's called what? This is forward. So what it is called? Backward reaction. All right? Backward reaction. Forward and backward reaction. Clear all of you? So reactant to products is called forward reaction. Product to reactant is called what? The backward reaction. Now, what is the meaning of equilibrium? Equilibrium means the state of a system when rate of forward reaction equal to the rate of backward reaction. What's the meaning? What's the meaning of rate? Rate means speed of a reaction. Correct. So rate of forward reaction, when it is equal to the rate of backward reaction, then you can call it as the system is under equilibrium state. Clear all? Okay. Now, the condition, we are going to discuss one of the principle called Chatelier principle. Okay, first I'm discussing about the theory, then we can go for some previous year NEET JEE questions. All right. Now, in the rate of forward reaction equal to rate of backward reaction, there's something we have to discuss detail at equilibrium state. At equilibrium state, suppose if you make any changes in these following, either concentration, okay? So your system now it is in equilibrium. What is equilibrium? They're in a relaxed format. They are in a relaxed state. There is no forward reaction, no backward reaction. Now both are equal. They are still alive and they are stable compound now. Equilibrium. Now we are going to disturb this equilibrium. Okay. Now we are going to disturb this equilibrium. What happened? You can disturb the equilibrium either by changing concentration of reactants or products. Or you can change in a temperature. If you increase the temperature or decrease the temperature, reaction equilibrium get disturbed. If you increase or decrease in pressure, definitely equilibrium will disturb. If there is a difference in number of moles, volume, if any of these factor when you changes, the equilibrium stage get disturbed. So the equilibrium try to stay alive in that disturbed state? Definitely no. They will try to compensate it. They will try to nullify that change and try to bring a new equilibrium. For example, you're going to write an examination. So what happened? You will be maybe tensed. All right. So before the examination or before 1 month of your examination, you will be in stable condition. Okay. I can study everything. You have a confidence now, which means you are in a stable condition. Suppose when you're going for examination, because of examination, you get tensed. So what happened? There is no need of tension actually, but still, because of tension, your equilibrium get disturbed. Your mind get disturbed. So what happened? Will you stay with that tension for a long time in your life? Definitely no. After the examination, after a few days, you will get a better result. So automatically you will change just to a new equilibrium. That is what happened in chemical reactions also. That is explained by Chatelier principle. Simply we can say that when a reaction is under equilibrium means rate of forward and backward when they are same. That's called equilibrium. When the system is in equilibrium state, when you make any changes in this following, either concentration, temperature, pressure, number of moles or the volume, the equilibrium get disturbed. But the equilibrium, the disturbed state will not stay for a long time. They immediately try to bring a new equilibrium by nullifying the change what happened. So definition wise we can say that what is Le Chatelier principle? All of you, if a system at equilibrium is subjected to the change in any of this factor, okay, hope you get the factor. We are discussing majority of the concept, first three, concentration, temperature and pressure. So when you make any changes in this parameter, definitely the equilibrium get disturbed. So what happened? Then equilibrium shift in such a way so as to undo the effect of the change. Means to nullify, to cancel the change what happened that's needed to become a new equilibrium. Alright, this is called Le Chatelier principle, what say. Now we can go for each of these parameters, how they will affect an equilibrium. Ready? First I am going to the effect of concentration on equilibrium. Let me consider a simple reaction. What is actually happening in a chemical reaction? Reactants are converted into what? Products. Alright, let me consider this is the forward reaction and this is the backward reaction. Now they are under equilibrium condition. Okay, so there is no movement. There is no forward, no backward, both are equal now. Now it is in equilibrium state. Clear all? Okay. Let's make a change in concentration. With concentration means you know the amount. Right, number of moles or something you're going to increase. For what? Either reactants or product. Let's see. You know the seesaw arrangement, right? You know the kids are playing in parks. Like we studied a seesaw, right? Seesaw. Right, seesaw. It's a balanced state, right? Suppose there are two student, okay, two person. Suppose the first student, the weight is around 20 kilogram, here also around 20 kilogram. Will there any movement? No. They are equal, right? They are 20 means they will balance. This is called equilibrium. Now they are under equilibrium condition. Now you are going to disturb the system. Alright, disturb the system means one more student entering into the part and is placed or sitting in the left part. What happened? What happened? This balance will be like this, right? Here the concentration increasing, here the number of students increasing. So what happened? Reaction shift like this. So the reaction, the equilibrium get disturbed, correct? This is what happening. So if you increase the concentration of reactant, if you increase the concentration of, if you are providing more reactants here, what happened? So here more reactants are there, here less products are there. From which part to which part reaction try to shift to attain the new equilibrium or to make this change cancel. To cancel this change, this more reactant if you added, here reactant side more concentration is there. So in order to reduce the concentration, reaction try to shift forward. You know, reactant to product is called what? Forward reaction. This is called what? Backward reaction, right? Backward reaction. So when you add more concentration of the reactants, so reactant side more concentration, product side less concentration, in order to attain new equilibrium, for more reactant, more concentration to less concentration, reaction can shift. So what happened? They will attain a new equilibrium. Alright, suppose I am increasing the concentration of product more. What happened? What happened? If you increase or if you providing more if you're increasing the concentration of product here, what happened? Product concentration greater, reactant concentration lesser. So reaction try to shift from higher concentration to lower concentration to attain new equilibrium or to balance the reaction. This is what happened. Now so many techniques are there. Let me explain with some of the simplest example, that's called Haber process. What is mean by Haber process? That's the industrial preparation of ammonia, NH3. The equation is N2 plus H2 gives equilibrium reversible reaction actually, therefore, and it is ammonia. Nitrogen and hydrogen combined together, you will get ammonia. Let me balance it. N2 plus 3H2 gives 2NH3. Hope it is already balanced. Alright. You know, nitrogen is a gas. Hydrogen is a gas. The form product also gas. Alright. Fine. This is called forward reaction. This is called backward reaction. Or I can say that formation of ammonia is forward reaction. Decomposition of ammonia is backward reaction. Correct? Yeah. Now, I'm going to change the concentration of this species. Okay, you tell me what happened. This is what? Forward. This is backward. I'm going to disturb this equilibrium. You tell me how you can attain new equilibrium. Alright. First of all, I'm going to change the concentration of nitrogen. The nitrogen concentration, let me increase. Let me increase the nitrogen concentration. You know, nitrogen is a reactant. So when you add more nitrogen in this left side, so left side, all your reactant side concentration is very much greater. Reactions start to move from left to right, which means which reaction will take place? Forward reaction takes place. This is the same thing happen when you add hydrogen concentration greater. If you increase the concentration of hydrogen also, the same thing going to happen, yes or no? Because hydrogen is also one of the reactant. When reactant concentration increases, forward reaction takes place. You will get some more amount of product. Then it is balanced. Alright. So here also we can say forward reaction takes place. Next condition, let me tell you. If I'm adding more amount of ammonia, I'm going to increase the concentration of ammonia, what's going to happen? If you increase the concentration of product, reaction starts to move from right to left. That means backward reaction takes place. Backward reaction takes place. So generally we can say that, as per concentration, how they affect equilibrium. Simple. Where you are increasing the concentration, reaction shift from higher concentration to lower concentration to minimize or to nullify the change. Alright. Now see, I'm just to mention some of the data, so some of the changes which I'm going to do here. Tell me which reaction can happen to maintain the equilibrium. First of all, N2 and hydrogen concentration, let me decrease. Alright. Nitrogen and hydrogen concentration, let me decrease. Which reaction can take place? Check it. Nitrogen and hydrogen concentration, let me decrease. I'm removing nitrogen and hydrogen from the system. So which reaction can happen more? Dear all, nitrogen and hydrogen, when you decrease, here is the high concentration. So higher to lower reaction will move. That means backward reaction will take place, right? Backward. Alright, one more data. Suppose the concentration of ammonia, let me decrease. Alright, the ammonia concentration, let me decrease. What happened? Reaction shifted from left to right, means more to lower. That's called forward reaction. Are you clear all? Let me go to the overall summary for effect of concentration. See, we can say the summary like this. First one, if the concentration of reactants increases, all of you listen, this is the reactant, here is the product. Once again, this is the reactant, this is the product. Alright, so reactant concentration, which is forward reaction, reactant, and this is product. Reactant to product is called forward, product to reactant is called backward. Sure? Okay. Now I'm going to increase the concentration of which one? Reactant. So reactant concentration increases. Which reaction takes place? To nullify this, reactant to product reaction will shift. So then will be balance. Correct? So reactant concentration when increases, forward reaction can happen. So we can say here it will happen forward reaction favor. So if the concentration of reactant increases, so this is the reaction, reactant to product. If reactant concentration when you increase, forward reaction will take place. If the concentration of reactant decrease, reactant concentration decreases, product to reactant, the reaction will shift. That's called backward reaction. Backward. Clear all? Next one. If the concentration of products increase, if you increase the product concentration more, what can happen? Higher to lower means again backward. Again backward. Please don't by heart this concept, all of you. Try to understand clearly. Okay, hope you're getting. Now, if the concentration of product decreased, product concentration when decreases, reaction shift from higher to lower means forward reaction. Clear all? This is the way how they affecting equilibrium by the change in concentration. Clear all? Okay, let's discuss maximum question today after the theory. Let me go to the next factor which is going to affect an equilibrium. That's called very important one, effect of temperature. Clear all? Effect of temperature is mainly depends on the reaction, whether it is exothermic or endothermic reaction. Okay, let's see. You know what is an exothermic reaction? All right. Exothermic from grade 10, 9. Everybody is studying about it. Exothermic reaction. Heat releasing process are called what? Exothermic. What is the opposite? Endothermic, right? Endothermic. Exothermic mean heat releasing process. Endothermic mean heat absorbing process. Clear? Okay. How can we find a reaction is exothermic? The given reaction is exothermic or endothermic. Easy one, you don't worry. They will give you a value called delta H. What is mean by delta H? Change in enthalpy. H represent enthalpy, delta represent changes. Delta H represent change in enthalpy, which represent the change in heat. Alright. If the delta H symbol is or the value is negative value, you can say that it is exothermic. Once again, if the enthalpy change is negative, reaction is exothermic. If the enthalpy change is positive, that's called endothermic. Fix it? Fix it in your mind? Alright. Delta H negative mean exothermic. Delta H positive mean endothermic. Alright. Let me go. I will give you the same example reaction what we discussed before. That is N2 plus 3H2 gives 2NH3. Okay. I'm just will give you the delta H for the reaction. It's around minus 92.4 kilojoule per mole. Delta H value already given. Okay, they will give you in your question paper. Delta H is equal to negative, dear student. Delta H negative means which reaction? Exothermic reaction. Fix it, no? Alright. I'm just taking the reverse reaction. Means this is formation of ammonia. Let me take the decomposition of ammonia. The backward reaction I can write like this. Dear all, here formation of ammonia is exothermic. So what will be the opposite decomposition of ammonia? It is endothermic with the same value. So delta H become positive. Okay, positive 92.4 kilojoule per mole. Clear all? That's it. Okay, so this is the way how to find out whether the reaction is exothermic or endothermic. Easy? Okay. Now, for an exothermic reaction, when you increase the temperature and decrease the temperature, what can happen? Okay, let's discuss. Dear all, generally for an exothermic reaction, generally for an exothermic reaction, we can say that, I'm just making the same equation once again, N2 plus 3H2 gives 2NH3. As I told you, this is already an exothermic reaction. Exothermic reaction means heat releasing. Means when the product formed at the same side, heat will be released. More heat produced means that means more product formed. So heat releasing process mean always you should write the heat on the right side, mean product side. So where is actually heat at the present equilibrium? Where is the heat greater? In product side, because when the product formed at the same time heat generated. So product side heat is already greater, no? Okay, reactant side heat is lesser. Fine. This is the case in normal every exothermic reaction. You already got it. It is an exothermic reaction. Now I'm going to change the temperature. I'm going to change temperature. What will happen in an exothermic reaction when you increase the temperature? Dear all, in exothermic reaction, already heat is greater in the product side. Already heat is greater in the product side. So, when you again increase the temperature, what can happen? When you again increase the temperature, here temperature increases mean not a specific side, okay? We're increasing to the whole system, alright? So, in exothermic reaction, already heat is very greater in product side because during product formation, heat is generating. So already heat is greater on this side. So again when you increase the temperature, what will happen? Already heat is product side greater. Again when you increase the temperature, reaction shift from higher temperature to lower temperature, which means backward reaction can happen. Backward reaction. So clear all of you? So in an exothermic reaction, when you increase the temperature of the system, backward reaction takes place. What about the opposite? When you decrease the temperature, just opposite reaction will take place. Which one? Forward reaction can happen. Clear all? So keep in mind or fix it. In an exothermic reaction, when you increase the temperature, keep in mind this is reactant, this is product. Clear? Where is greater heat in the equilibrium state if it is an exothermic reaction? Product side. Alright, already product side heat is greater. Again when you increase the temperature of the whole system, reaction shift from higher temperature to lower temperature, which mean backward reaction. So temperature decreases mean forward reaction. Let me go to endothermic reaction. Endothermic reaction. Endothermic reaction means, as I told you, it is heat absorbing process. Who can absorb to give product? Reactants are absorbing. Exothermic means during the production of heat, the product, heat is generating. So product side heat is already greater. Endothermic reaction mean heat absorbing process. Heat absorbing process, right? Heat absorbing. Who is absorbing heat to get the product? Reactants are absorbing. So exothermic reaction, while you're writing, write heat on right side, and endothermic reaction, while you're writing the same opposite reaction, let me take, as I told you, no. This is for exothermic mean, reverse is endothermic. Okay. So where you want to write heat, dear all of you? In reactant side. Okay. If it is endothermic reaction, we have to write heat on reactant side. Heat on reactant side. So if it is an endothermic reaction, already heat is greater in which side? Reactant side. Then just opposite can happen, right? Yes. When temperature increases, what happen? Already heat is greater in reactant side. Again, when you increase the temperature, to minimize that, forward reaction takes place. What about temperature decreases? When you decrease the temperature, backward reaction can take place. Backward reaction can take place. This is fixed for most of the exothermic and endothermic reaction. Let me conclude. For an exothermic reaction, when you increase the temperature, reaction shift backward. Alright? When you decrease the temperature, forward. For an endothermic reaction, when you increase the temperature, what happened? Forward. When you decrease the temperature, backward. Let's go for the summary. In exothermic reaction, increase in temperature. Okay, once again, exothermic means reactant is there, it giving you product. Where is heat already greater? Product side. Alright. So this is exothermic. What about endothermic? This is the reactant and heat is reactant side. It's giving you product. Clear all? Okay. Now, in an exothermic reaction, already heat higher on the product side. Again, when you increase in temperature, reaction shift backward. So we can say here, the reaction shift backward. So for decrease in temperature, just opposite, forward. Forward. What about endothermic reaction? Finally, in endothermic reaction, heat is already greater on reactant side. Again, when you increase temperature, reaction shift forward. Reaction shift forward. What about decrease in temperature? Backward. Okay, clear all? Please don't by heart, dear student. Try to understand the concept. Hope you clear how the equilibrium effect or the changes with the effect of temperature and concentration. Now I'm going to the third factor affecting equilibrium, that is nothing but pressure. Pressure. Keep in mind, all of you, effect of pressure we can apply only in gaseous system. Alright, gaseous state. If the reactants and products are in gaseous state, you know, effect of pressure only in the state which one? Gas. Liquid and solid are not majority, they are not affected by a change in pressure, right? So pressure only applicable to gaseous system. If your reactants and product are in gaseous state, you can apply this concept, or reactants any one of the side. The gaseous systems only pressure is applicable. Clear? Let me discuss detail. Let me take the same example which we discussed before, that is N2 plus 3H2 equilibrium with 2NH3. Alright? What is the state of, if you want to explain the effect of pressure, we should need the help of the reactants and products are in which state. You know, nitrogen is a gas, hydrogen is a gas, ammonia is also gas. Yes, here pressure is applicable because pressure effect on gaseous system. Now, one more factor let me give you. Pressure effect depends on, the pressure effects depends on number of moles of gaseous reactants and products. What? Effect of pressure mainly depends on the number of moles of gaseous reactant and gaseous product. It's simple. Can you tell me, this is your reactant, this is a product. How many moles of gaseous reactants are there? Here both are gases. How many moles are there? What is the moles? Just take the coefficient. Here the coefficient is 1, right? 1 nitrogen, 3 hydrogen. Total 1 plus 3, total 4 moles of reactants are there. Gaseous reactants are there. Clear? If it is so, how many gaseous products are there? 2 are there. 2 moles are there. Okay, 2 moles are there. Clear all? So if you want to say the effect of pressure, just take the number of moles of gaseous reactant and gaseous product here and there. Now let's see. I'm going to increase the pressure of the system. Okay. Pressure of the system means I'm not applying on reactant side or product side individually. To the whole system, I'm just applying pressure greater. From which side to which side reaction can shift. Let's see. If pressure increases, this is the theory. If pressure increases, reaction shift from high number of moles to low number of moles. Clear all of you? If you increase the pressure of a system, reaction shift from higher number of moles to lower number of moles. Where is higher number of moles? In this case, 4 moles are there. Where is the lower moles? 2 moles. So when you increase the pressure of the system completely, you can say that reaction shift from higher moles to lower moles. Means, what is this reaction? Forward reaction. Here it is, forward reaction. Then what about if you decrease the pressure? If you decrease the pressure, reaction shift from lower number of moles to higher number of moles, which means backward reaction. Backward reaction. Let me give you one of the other equation. You tell me what's going to happen. Suppose H2 plus Cl2 gives HCl. Okay, H2 plus Cl2 gives HCl. If you balance it, you will get 2 HCl, correct? Alright. So 1 H2, here 1 H2, 1 Cl2 reacting, you are getting 2 HCl. Suppose you consider all systems are in gaseous state. All reactants, this is hydrogen gas, suppose chlorine gas, the formed HCl also, suppose you consider it is gas. Suppose I am going to increase the pressure. Can you tell me which reaction can happen, whether forward or backward? If you want to know that, the effect of pressure, first of all, we should know what is the number of moles of gaseous reactant and product in both sides. How many gaseous reactants are there? 1. There are total 2 moles. How many gaseous products are there? Here also 2 moles. Here both side number of moles are similar. So what happened? If both side, reactant and product side, the number of moles are same, we can say that there is no effect of pressure on this equilibrium. Clear all of you? So general, what is the trend of pressure? Pressure increases, reaction shift from higher number of moles to lower number of moles. Pressure decreases, just opposite. So let's go for the summary. Increase in pressure. If you increase in pressure, reaction shift from what we said? High number of moles to low number of moles. Okay, always. If you decrease in pressure, then the reaction shift from just opposite. Low number of moles to high number of moles. High number of moles. Let me give you one more example for understanding the concept clear. For example, PCl5 splitted, it's giving you PCl3 and Cl2. Okay, suppose this is the reaction. I'm giving you all the reactants are gases. Suppose what can happen? Immediately you calculate the number of moles left and right side. How many moles are there left side? Only see the coefficient, that's it. How many moles are there? Just 1 mole. How many coefficient? How many moles of products are there? 1 PCl3, 1 Cl2. Total there are 2 moles. Tell me, dear student, if you increase the pressure, what can happen? We studied, if you increase the pressure, reaction shift from higher number of moles to lower number of moles. Where is the higher number of moles? Right side. So the reaction shift from 2 moles to 1 mole. What is this reaction is called? Product to reactant is called backward reaction. So we cannot fix it if you increase the pressure, always it is forward or backward. It depends only on the number of moles. Clear all? So, okay. So what are the major factors affecting the equilibrium? Concentration, temperature and pressure. Some more factors are the number of moles and volume. That's not a important one. Important in the sense, number of moles means what? The concentration only. And volume. How volume affecting? You know, volume is inversely proportional to pressure. Correct or not? Volume inversely proportional to pressure. You know, P is inversely proportional to volume, or volume is inversely proportional to pressure. When you increase the pressure, volume decreases. You know how effect of pressure, correct? When you increase the pressure, reaction shift from higher number of moles to lower number of moles. Then you can say about the volume effect also. Just take the opposite because pressure and volume are inversely proportional. Let's see some of the questions. Okay. Let's go for the first question, all of you. Read carefully. Read carefully. Let's make the concept clear through these questions. Consider the equilibrium setup. Let me just write the reaction once again. 2H2, it's a gas, plus carbon monoxide, it's a gas, giving you CH3OH, that's called methanol. It's also gas. Question, what will be the effect of the following on equilibrium of the reaction? You're going to make 4 changes. Let's see. Which is forward, which is backward here all? This is called forward, this is called backward. Alright. First question, addition of H2. When you increase, when you add again some more hydrogen, which reaction can happen? Can you tell me? When you increase the concentration of hydrogen here it is a reactant. We studied when reactant concentration increases forward, in order to change the effect, the forward reaction can happen. So first system, addition of H2, we can say the answer is forward reaction, forward. All right. What is the second they are doing? Addition of methanol. Where is the methanol? Methanol is in product side, which means you are increasing the concentration of product. So reaction shift from backward. Reaction shift towards backward. All right. Removal of CO. This CO is in reactant. So you are removing CO, which means you are decreasing the concentration of CO. So what happened? Here lesser, here greater. Greater to lesser, which means again backward. Again backward. Right? What about the last one? Removal of methanol, dear all of you. Methanol is the product. You're removing that. Removing means the concentration will decrease. So reaction shift from higher to lower. That means again forward. Clear all? So forward, backward, forward, forward, backward, backward, forward. What is that? That's option A. Clear all? Let's go to the next question. Here we have formation of ClF3 from chlorine and fluorine is an exothermic reaction. As I told you, they will give you which is endo or exo. Okay, don't worry. Let me write the reaction once again. Cl2, it is a gas. 3 fluorine, it's a gas. It's giving you ClF3. Alright, ClF3. Okay, let's balance it. Cl. See, what is the delta H enthalpy given? It's minus 329 kilojoule per mole. See, minus value, as I told you, it is an exothermic reaction. It is a exothermic reaction. Alright. Now the question, which of the following can increase the quantity of ClF3 in the equilibrium? What's the question? Through which of the changes you can increase the concentration of ClF3? Dear student, if you want to get more amount of ClF3, whether you need forward or backward reaction, tell me. I think forward, because chlorine and fluorine combining, you're getting ClF3. That is called forward reaction. ClF3 decompose, you will get chlorine and fluorine. That is called what? Backward. Question, what are the techniques we can use it to get more amount of ClF3? Which means you want to get more amount of forward reaction. Okay. So let us do that. Let me discuss the questions. They given temperature. They in most of the option they given temperature and pressure. Let's see, actually without looking to the option, what we need to get more amount of ClF3 in temperature and pressure, what the changes we have to make. Okay, you know it is an exothermic reaction. We studied that in an exothermic reaction already heat is greater on the product side. Again, when you increase the temperature, reaction shift backward. But we need forward. So what you have to do in temperature? Temperature should be decrease. Clear all? Next one. Pressure. Pressure. What is the effect of pressure? If you want to know pressure effect, we studied that. You have to know about the idea about the number of moles. Here all are gases. How many moles of reactants are there? 1 chlorine and 3 fluorine. Total there are 4 moles. How many products you have? Only 2 moles. Okay. If you want forward reaction, reaction should shift from higher number of moles to lower number of moles. Correct? 4 to 2. What is this reaction? Forward reaction. Yes, we need forward reaction. So what should do in pressure? Pressure should increase. We studied, no, when you increase the pressure, reaction shift from higher number of moles to lower number of moles. Yes, pressure also increase. And last they given addition of chlorine like that. If you want to get more amount of ClF3, what all things you have to add here all of you? Reactants, chlorine and fluorine, you have to add more. So reaction shift right side. Yes. So what's all together? The answer is possible. Temperature should decrease and pressure should increase Yes, I think option D is the correct answer, right? Decrease in temperature, increase in pressure, and addition of more fluorine. You will get maximum amount of ClF3. Now, are you clear? What is the need of Le Chatelier principle in equilibrium? Alright, next question. Which of the following reaction will not, right, will not affected on increasing pressure? We studied when pressure is an invalid system. Two things. One is whether the system, the reactants and products are in solid or liquid state, there is no effect of pressure. Second one, in the left and right side, the reactants and product side, if the number of moles are equal, then also there is no effect of pressure. So you see all of you, I think here all systems are given gases. All reactants and products are gases. So definitely there is something effect. Then next factor what we have to consider, in reactant and product side where the number of moles are equal, then there is no effect of pressure. See, how many reactants you have? 2 plus 1, right? 2 plus 1, total 3 moles of reactant. Here only 1 mole. Definitely there is a effect of pressure, right? When you increase the pressure, reaction shift from higher to lower, right? So that's not that. Next one, B. How many moles of reactants are there? 4 moles here, 5 moles here, total 9 moles reactant. Here 4 plus 6, total 10 moles reactant. They are also not equal. Definitely they will affect by pressure. In C, 1 mole methane and 2 mole, total 3 moles reactant. Here 1, 2, total 3 moles. Dear all of you, in option C, reactants and products are in same number of moles. So when you increase the pressure or decrease in pressure, there is nothing affects. So option C can be the. What about the last one? That's already we discussed one of the example, right? This is 1 PCl5. So 1 reactant, 1 plus 1, total 2 reactant. Yes, they are not equal. So affect by pressure. Next question. In which of the following reaction the increase in pressure will favor the increase in product? Alright? You know, reactants converted into product. They need maximum amount of product. So which reaction you have to favor? Forward reaction. Forward reaction, you want to get it more. And they already said you're going to increase the pressure. Dear student, increase in pressure, what is the shift happen? When you increase the pressure of the system, reaction shift from higher number of moles to low number of moles, correct? So where should be higher number of moles? Your reactant side should be high number of moles and your product side should be low number of moles. Low number of moles. Then only the reaction shift to right. Then only the reaction shift from reactant to product, forward reaction. Let's see. In which reaction, given reaction, your reactant side high number of moles and product side low number of moles, then reaction can happen forward. See, I think all are gases, right? Gases. Okay. Here 1 nitrogen, 1 oxygen. So total 2 moles left. Here 2 moles right. So it is not affected by pressure. How many moles of reactant left side? 1 PCl3, 1 Cl2. Total 2 moles left side and 1 mole right side. Yes. Here reactants having greater number of moles, product having lower number of moles. When you increase the pressure, what happen? Reaction shift from higher number of moles to lower number of moles. Yes, it can be the answer. What about here? 1 PCl3, here 1 plus 1, 2. See, it is opposite. Here 2 reactant and here 2 plus 1, 3 reactant. Yes, see, if you increase the pressure in C and D option, what will happen? Reaction shift from higher number of moles to lower, means backward will take place. Here we need what? Forward reaction. Clear all? So option B is the answer. Next one. In a vessel, nitrogen, hydrogen and ammonia are at equilibrium. Some helium gas is introduced into the vessel so that total pressure increases while temperature and volume remain constant. According to Le Chatelier principle, dissociation of ammonia. Here all, you know, ammonia on dissociation we studied. We will get N2 plus 3H2. right? Ammonia on decomposition, we will get nitrogen and hydrogen gas. Clear? Now, the question, you're going to add which gas? Helium gas. All of you, please note that we studied what are the factors affecting equilibrium. Correct? Concentration, temperature, pressure, number of moles and volume. Which all factors are not affecting temperature? Please note it. Mainly catalyst. Catalyst and inert gases. You know, inert gases. What are inert gases? Helium, neon, argon, krypton, xenon, etc. Catalyst and inert gases having no effect on equilibrium. Clear all? Catalyst and the noble gases, inert gases, when you added, that's equilibrium not disturbed. So here, I think here you are adding helium gas, right? Helium gas is a noble gas. Noble gas is an inert gas. It's having no effect on equilibrium. So what we can say, the equilibrium remain unchanged, no effect. Keep in mind, catalyst and inert gas having no effect on equilibrium. Next one. When I2 dissociate to its atomic form, you know, I2 is a molecule, right? Iodine is a molecule. When it is decomposed, you will get 2 iodine atom. That's also in gaseous state. They already said the enthalpy of the reaction is a positive value, which means it is a endothermic reaction. Delta H positive mean endothermic reaction. Okay, now let's go. The question, the reaction favor what condition? Which reaction? What reaction? They given decomposition of I2. So I2 is a molecule, one I2 molecule. They decompose, you are getting 2 iodine, which means they are asking you forward reaction. Because forward reaction is the decomposition of iodine molecule to 2 iodine atom. Correct? So they are asking you, when I2 dissociate to its atomic form, which reaction, this reaction favor at what condition? Means, at the when you make these changes, which all changes can bring a forward reaction? Let's go. Here, this is an endothermic reaction, right? Because delta H is a positive value. What we studied, in an endothermic reaction, heat is already great on reactant side. Again, when you increase the temperature, we studied that reaction shift from higher heat to lower, means forward reaction. Yes, that's what we need. So we can increase the temperature. Increase the temperature. Is it there? Lowering temperature, no dear student, high temperature. Clear the concept? It is already a endothermic reaction. We studied in endothermic reaction, already heat is greater on the reactant side. Again, when you increase the temperature of the whole system, reaction shift from right, means left to right, means reactant to product side, which means forward reaction. So more iodine you can decompose to iodine atom. Clear? What about no change with the temperature? High pressure. High pressure is a factor? No. Dear student, high pressure. Here how many moles are there? Just 1 mole reactant. How many moles are there? 2 moles reactant. So greater mole is on product side. When you high pressure, when you increase the pressure, what happen? Reaction shift from higher number of moles to lower means. That means backward will take place. That's what we don't want, right? We need forward reaction. Correct? So option B. Next one. For the reaction is given PCl5, it's a gas, equilibrium with PCl3 gas and Cl2 gas. Okay. The forward reaction at a constant temperature is favored. So we need forward reaction more. Okay. We need forward reaction more. Means reactant should convert it to product. What condition you can make it? Introducing an inert gas. Dear student, inert gas and catalyst having no effect on equilibrium. We don't want. Introducing chlorine at a constant volume. Where is chlorine located? Product side. Which means you are adding so much chlorine. What happened? Product concentration increases. Reaction shift backward. We don't want. Introducing PCl5 at a constant volume. Introducing PCl5. Where is PCl5 reactant? Yes. PCl5, if you added more, reactant concentration increases. In order to compensate that, it will react or it will move forward. Yes, that's what we need. Reducing the volume of the container. No. Reducing the volume of the container. So let me tell you what is the effect of volume. Okay. As I told you, when they asking question with a volume, you can relate with the pressure, because pressure we know how it is varying. You know, pressure and volume are inversely proportional. Here reducing the volume means, can we say increasing pressure? Yes, right? Decreasing volume. Reducing means decreasing in volume means we can say increase in pressure. What can happen when you increase the pressure? Tell me. Here you have only 1 mole reactant. Here 1 plus 1, 2 moles reactant. Tell me, when you increase the pressure of the system, reaction shift from higher number of moles to lower number of moles, which mean backward. Do you want backward? No, here we need forward. Clear all of you how to connect volume and pressure? So when they given volume data, you make into pressure. One last question all of you. The reaction is given 2 SO2 plus O2 gives equilibrium with 2 SO3 plus heat. Dear all of you, they given heat on right side, which means it is exo or endo? It is exo or endo? Exothermic. Yes, very good. This is what? Exothermic reaction. Exothermic. You know, in exothermic reaction, already heat is greater on product side, right? What you need? The reaction will be favored by. What is the reaction? SO2 combined with the O2, you are getting SO3. This reaction favor, which mean forward. Right? Reaction is sulfur dioxide combined with oxygen, you are getting sulfur trioxide. This reaction favor at what condition? Already you got it. It is exothermic reaction. I think the question is related to temperature and pressure. Let's go for the answer. Since it is an exothermic reaction, we studied that already heat is greater on the product side. Again, when you increase the temperature of the system, reaction shift from right to left, which means backward. We don't want that. So temperature should not increase, it should decrease. So we need low temperature. Okay. What is the effect of pressure? Count the number of moles, all of you. This, I think, all are gases. Yeah, all are gas. Sulfur dioxide is a gas, oxygen is a gas, trioxide is a gas. How many moles of reactant is there? 2 plus 1. Total 3 are there. How many products are there? Just 2. How you can perform forward reaction in change in temperature? When you increase the temperature, reaction shift from higher to lower. Yes, that's what we require. So pressure should be increase. Where you can identify these two conditions: low temperature, high pressure. Low temperature, high pressure. That is in option B. Clear all? So this is the main application of which principle? Chatelier principle. Once again, when the reaction is in equilibrium, it's almost in a stable condition. When you make any changes either in concentration, temperature, pressure, or number of moles or volume, what happens? Equilibrium get disturbed. In order to nullify the change, in order to undo the change, what happened? Reaction shift either forward or backward, and they will compensate and they will try to bring a new equilibrium. This is called what? Chatelier principle. Hope you clear what type of questions you can expect for the competitive examination. Clear all? So this is about Chatelier principle. Let's meet with again some more concept from the same chapter, equilibrium. For that, bye all of you.